It's all about slope fields, but we need to learn what a slope field is. So we're going to backtrack a little and first talk about what is a differential equation. And a differential equation is really just a derivative, just a fancy name for a derivative. So let's write out the actual definition. A differential equation is an equation that specifies a derivative. And you guys know a derivative, another way of describing a derivative is really just slope of the tangent line. So maybe write that down, that aka a differential equation really just gives you slope of a tangent line. It's another way of thinking about it. All right, so let's look at the example dy dx equals 2x. This is an example of a differential equation, right? Dy dx is a derivative. So we're saying the derivative is 2x. And you guys know it can be written as dy dx. It could also be written, as maybe sometimes they say y prime equals 2x. Sometimes we use the notation f prime equals 2x. All right, but really all those mean the same thing. And since we're prepping for the AP test, they might write it a little bit different. So we just need to kind of prep ourselves to know that all of those mean the derivative or a differential equation. So it says state 3 possible antiderivatives of dy dx. So think we're working backwards, starting with 2x. Think if we're working backwards, what was the original function? All right, you could probably think that it's going to be x squared, right? If we took the derivative of x squared, we'd be back at 2x. The 2 would just go out in front. The exponent would be 1. So we get 2x. So I think that would be a possible antiderivative. It could have that plus c, a constant on the end. So maybe another one would be x squared plus 4. Maybe another example would be x squared minus 9. All right, really, it could have any constant on the end or no constant at all. All right, the next one says state the general antiderivative of dy dx. So we're talking about the same, all right, differential equation up here, dy dx equals 2x, general antiderivative. You guys know general just means you need a plus c. So it would be y equals x squared plus c. All right, so next we have to talk about what a slope field is. I like to draw it first. So over here, all right, on the right, if you guys look, we have a bunch of parabolas. So we have a bunch of basically x squared graphs, if you look at this. And basically we have all, a lot of antiderivatives that we could have had. We said it could have just been x squared, all right? This first one, all right, x squared would be, going through the origin, all right? This one would be, x squared plus 3, moving it up 3. We've got x squared minus 3, moving it down 3. And then the green one is even moving it down further. But we just have kind of a few possible antiderivatives graphed there. All right, so I think it's important to remember, all right, that these antiderivatives in this case, all right, the original function y will be some sort of parabola. It could be moved up or down depending on what constant you have or if you have a constant at all, but it's going to be some sort of parabola. All right, and really all a slope field is, all right, is if you look at your original function, the graph of it, and you were to draw in, just mini tangent lines. And we do this all the time. We just draw in a bunch of mini tangent lines. And we could do this for all of the possible graphs because, again, we don't know which one was the original function. And if you draw in these mini tangent lines, what is formed is called a slope field. All right. And a slope field all it is made up of those mini tangent lines. All right, it's just a visual diagram of the slope of the original graph at any point. Really just shows that slope. So let's write that down. Basically, all those little marks in orange that I just did create the slope field. If we were to erase the original graph, all right, erase those parabolas and just have those mini orange lines, that would be our slope field. All right, so we can say slope fields are a visual diagram of the slope of the original graph at any given point. All right. So let's do an example. In example 1, it says plot the slope field. So we're literally just going to be drawing mini tangent lines. If you look, there isn't an original graph for us to just follow. It's not as easy as the first one. All right, we have to kind of figure out the slopes at all the points that are present, and then we're going to draw a mini tangent line that has that slope. All right, and then after that, it says draw the possible solution curves for each function with the initial values, y of 0 equals 1, y of 0 equals -2. All right, we'll talk about that later. For now, let's just really first talk about the first part, plot the slope field. All right, so if we don't have the original graph to just follow and draw those mini tangent lines, what we have to do is we have to use our differential equation, our derivative. All right. And I have listed out literally all the points that we have here. All right. If you guys look, all right, I think these points right here, these first few, my highlighter never works. I'll just put dots by them. These first 5 points, all right, those are all these points over here. All right, if you think about them, all the x values are -2. So let's work with those first. All right, we got to find the slope at each point. So what we're going to do, we're going to take those x and y values, this first point, -2, 2, and we're going to plug it in to our differential equation. All right, so it's x plus y. So our x is -2 plus our y value is -2 all over our x value, which is -2, minus our y value, which is -2. That's a double negative. So when we do the math, we get -4 on top, all over 0. We get undefined. So the slope there is undefined. And let's think about when you graph a line that's a slope of undefined, that's a vertical line. All right, so we're going to do a mini vertical line at the point -2, 2. So if we go left 2, down 2, the point -2, 2 is the very bottom point on the left. All right, if we were going to graph a mini tangent line that has a slope of undefined, it would just be a mini vertical line right there. All right, so let's do the next point. This is going to be tedious, all right, but not very hard. All right, the next point, -2, -1. So on the top, we add our x values, -2 plus a -1. On the bottom, we subtract our x values, -2 minus a -1. So we get -3 over double negative on the bottom, -1. If we divide that out, we get +3. All right, so we need to graph a mini tangent line that has a slope of +3. Let me switch colors for this. So at -2, -1, at this point right here, all right, we need to graph a line that has a slope of 3. So think from this point, a slope of 3 would be up 1, 2, 3 over 1. All right, think if we graphed a line that had a slope of 3, this would be the line. But again, we're doing mini tangent lines. All right, that's the right slope, up 3 over 1. But we just want a mini version. So I'm going to go ahead and erase all that and do kind of a mini version with that same slope, you try to point it at this point, and it doesn't have to be perfect, but it should be somewhat accurate. All right, so that would be a slope of 3. All right, let's do the next point. Again, very tedious, but not too difficult. All right, and you could probably start to do these in your head a little bit. For the next point, -2, 0. If we add our x and y, you're going to get -2. If we subtract them, -2 minus 0 is a -2. Divide that, you get +1. All right, so through -2, 0, if you're going to have a slope of +1, that would be like up 1 over 1. That line would be like a slope of this. All right, but we don't want the whole line. We want a really tiny version of it. So think that same slope, that same angle. Just draw kind of a tiny version of it. Try to be pointing it at this point right here. That would be a slope of 1. All right. Next one, -2, 1. All right, if we add our x's, it's going to be -2 plus 1. If we subtract them, -2 minus 1, you get -1 over -3, or you get +1/3. All right, so again, at this point, you go up 1 over 3. All right, if we were graphing the whole line, it'd be at that angle. Again, we only want kind of a tiny little version of that. Only a tiny little version, all right? And then we could go back and kind of erase the big version and all that other stuff so it's not as messy. All right, keep going. Gotta fill in this whole chart. All right, the next one, we add our x's and y's. It's going to be -2 plus 2, and then -2 minus 2. All right, so we get 0 on top, all over -4 on bottom. 0 divided by -4 is 0. You guys know 0 is a horizontal line, so you just do a mini horizontal line. All right, and we kind of keep going. This is one of the harder problems, because this differential equation that we were given involves x and y. A lot of times they only involve x, which makes the work a little bit shorter. So this one's just kind of a long one, so we just got to keep going. All right, let's start on these next points, the -1s. That'll be this whole column right here. I think we're starting from bottom to top. All right, so let's start doing the math. We add the x's, so you get -1 plus a -2 all over -1 minus a -2. Double negative on the bottom, you get -3 over 1, which is -3. And this one might be a little bit trickier. How do you do a slope of -3? All right, you kind of have to go backwards. You guys know -3 would be down 3 over 1. You could kind of go like this and go like this, up 3 over 1. This would be a slope of -3. That would be the perfect angle. And again, they don't have to be perfect, so you don't have to, draw that whole line every time, but you do want them to be somewhat accurate in comparison to each other. So that would be a -3. Again, we only want kind of a mini version of that at that angle, and then you can kind of go back and erase all the other stuff that helped you, come up with it. And of course, I erased the actual little mini tangent line too. All right, on to the next one. All right, -1 and -1. You could probably start doing it without showing the work. If you add the x and the y, you get -2 all over. If you subtract, it'll become -1 plus 1, which is 0. You get another undefined, and undefined is just a vertical line. So you can put a vertical line through here. All right, add -1 and 0, you get -1 all over. If you subtract them, you get -1, which is +1. So think about a slope of +1. That would be like up 1 over 1. We're pointing it at this point, and you can just kind of eyeball it. Doesn't have to be perfect. All right, keep going. If you add the numerators, you get 0. If you subtract them, Negative 1 minus 1 is a negative 2. You get 0. 0 is a horizontal line. Should be pretty easy. All right, the next point, negative 1, 2, add your numerators. You get 1. If you subtract negative 1 minus 2 is a negative 3. You get negative 1/3 there. So think from this point, you go down 1 over 3. We're pointing it at that little point right there, something like that. Again, doesn't have to be perfect. It just has to be somewhat accurate. You know, if it's a negative slope, it better be sloping negative. If it's a positive slope, better be sloping positive, and they better be all accurate in comparison to themselves. All right, let's keep going. The next points, all these zeros, these are the ones in the middle. Zeros should make life a little bit easier to do. All right, the differential equation, we should add our x's. So you get negative 2. If you subtract 0 minus a negative 2 becomes a positive 2. So you get negative 1. So at 0, negative 2, we have a slope of negative 1. Something like that. All right, we add our numerators, you get negative 1. If you subtract them, 0 minus a negative 1, it's actually a positive 1. So you get negative 1. All right, same slope. You don't even have to think about it again. Add your numerators, you get 0. Subtract them, you get 0. Can't divide by 0, so you get undefined. Undefined is a vertical line. All right, add your numerators. If you subtract, 0 minus 1 is a negative 1, so you get negative 1. So something like this. All right, and then in the numerator, add. In the denominator, subtract. You get negative 1 again. So that was kind of easy. And there will be lots of them like that where you kind of see a pattern and really do the same thing over and over again. All right, let's keep moving. Again, I know this is tedious, but the nice thing is it's not hard. All right, it takes a lot of time, but it's not very difficult. All right, if we add our numerators, 1 minus 2 is a negative 1. If we subtract 1 minus a negative 2, that's a double negative, turns positive. That's negative 1/3. So negative 1/3 probably looks something like this. I'm kind of thinking backwards. If we went up 3 over 1. Ooh, and I did that wrong. Scratch that. Let me erase that. Sorry, guys. I erased a few along with it. All right, so negative 1/3, that would be down 1 over 3. I think we're pointing more over here. It'd be like this point, down 1 over 1, 2, 3. That would get you negative 1/3. All right, keep it moving. Add the numerators. If we subtract 1 minus a negative 1, we actually end up adding. You get 2, which is 0. 0 is a horizontal line there. That's an easy one. 1, 0, add the numerators. If you subtract 1 minus 0 is 1. You get 1, slope of 1, something like that. For the next one, we get 2 over 1 minus 1 is 0. You get another undefined. That's a nice one. An easy vertical line. All right, and then we add our numerators. You get 3. If you subtract 1 minus 2 is a negative 1, you get negative 3. So negative 3 would be something like down 3 over 1. Probably pointing it there. If you want to see the visual, how I knew that, from that point, if you go down 1, 2, 3 over 1, I was pointing it at that point right there. And again, you know, doesn't have to be perfect. You're just kind of giving yourself a little visual there. All right. Keep it moving. We got one more set of points, these 2's. All right, that last column. Again, add your numerators. You get 0. If you subtract 2 minus a negative 2, you're actually ending up adding. You get 0, which is a horizontal line here. All right, 2 minus 1 is 1. 2 minus a negative 1, you add them, you get 3. That's 1/3. So think up 1 over 3, maybe something like that. All right, if we add our numerators, we get 2. If we subtract, we get 2. So you get positive 1. So positive 1, maybe something like that. If we add, And then we subtract. 2 minus 1 is 1. You get 3. So 3 should be a little bit more vertical. And again, they don't have to be perfect, just kind of in comparison to themselves. If you have a slope of this slope was 1, this slope was 3, 3 should definitely be more vertical. If you don't want to think about, 3 is up 3 over 1, just think compared to the last one I did, it needs to be more vertical. They have to be correct in comparison to themselves, but do not necessarily have to be the perfect slope. No one's going to get out a ruler and say, did you go up 3 over 1? Or does it look more like up 4 over 1? All right, so you just kind of have to be close and kind of going in the right direction. All right, add the numerators. If you subtract 2 minus 2, you get 0. For this one, you get an undefined, and of course, undefined is a vertical. All right, so that is your slope field. All right, next step they wanted us to do. All right, they wanted us to draw a possible solution curve for each function. All right, with the initial values, the first one is y of 0 equals 1. All right, so I'm going to do this in black. I'm going to try to make it a little bit thicker so you guys can see it. But y of 0 equals 1, that's just that point, 0, 1, and that's really, really thick. Try to make it a little less thick so you can actually see it. All right, they're just saying that's the point 0, 1. All right, 0, 1 is this point right here. They want us to draw a solution curve through that. A solution curve is really just the original graph. We have the slope field. If you look back, it would be like us drawing one of these parabolas up here. All right, if we had all those little mini orange lines, it'd be like drawing one of those parabolas. And it doesn't have to be perfect, but usually I kind of just think of, those mini orange lines as kind of a path. And I try to just kind of pick a path and just draw a curve in the middle of it. Doesn't have to be perfect, but something that just kind of follows the path. All right, and they're giving us a specific point to start with because a lot of times there's many solutions. So, if they said start with the point 0, 2 right here, and you just draw the parabola that kind of fits in that path. Again, these don't have to be perfect answers. All right, they're truly just a sketch that follows the path. So they gave us our point. We have to somehow follow the path and kind of go with the slope. Maybe have something go out this way, and then down here, something go out that way. All right, I just kind of chose a path. If you chose a tiny bit different, say for that second part, if you kind of saw it differently and said, I'm going to go up this path right here, that would be correct too. All right, they're not very picky about this. All right, and then there's one other solution curve they want us to draw. All right, through y of 0 equals -2. So they're saying start at 0, -2. So 0, -2 is right here. And this one might look different. In our last problem, all the graphs were parabolas. This one could look a little bit different. Again, just follow a path and just kind of pick it and kind of go that way. That was a path I saw, and then maybe kind of out this way. All right, different shape than the other graph, and that's okay. But these would be those solution curves. We started with the points they wanted and just drew something through the path. All right, I know that was long. All right, hopefully they won't all be as long as that. This one should be a little bit easier. It's the same thing. Give it a try. All right, pause the video. See if you can do it. Hopefully the differential equation here is a little bit easier. You're only adding the x's and the y's, so you could do most of the math mentally. All you do, is add your numbers in your head. For this first one, -2 and -2, you get -4. All right, so take a minute to do that. Give it a try. Pause it, and then we'll check our answers in a moment. All right, so, one way to check, you could definitely check my numbers in the table. And then again, for this slope field, just to make it go quicker, I'm just going to eyeball it. All right, as I start here, all right, for my first column of points right here, all right, they start with -4. -4 is definitely a negative slope that's pretty negative, pretty steep. So I'm just going to kind of say that's -4. And then if my next one is -3, all right, it's going to be still negative, but maybe just a little bit flatter. And then my next one is -2, maybe a little bit flatter than that. My next one's -1, a little flatter than that. And my next one is 0, horizontal. All right, again, doesn't have to be perfect. They just have to be correct in relationship to themselves. All right, so my next row, all right, this column, same thing. I'm starting with -3. All right, make it pretty negative. Maybe that's something like -3. Then I've got -2, a little less negative. Then I've got -1, a little less negative. Then I've got 0. All right, and then I've got +1. So kind of switching in the other direction, +1 right there. So you could start to go a little bit faster. Now we've got the zeros. All right, the first one's -2. So think, down 2 over 1. All right, again, doesn't have to be perfect. Definitely should be negative. Then -1, a little less steep. Then we've got 0, a horizontal line. Then we've got +1 and +2, a little bit more steeper. All right, moving on. Now we've got the next row of points. Starts with -1, so it should be sloping negative. Then we've got a 0. Then we've got a +1. +2 is a little bit more steep. And then +3 is a little bit steeper. Again, just make them make sense in relationship to themselves. All right, and the last one, we've got 0. We've got +1. We've got +2, a little bit more vertical, +3, a little bit more vertical, and +4, a little bit more vertical, but not quite straight up and down. All right, something like that is a quick way to do it so you don't have to think too hard every time. All right, so that's our slope field. Step 1, plot the slope field. All right, step 2, we need the solution curves. So the first one goes through the point 0, 1. So find 0, 1, that's this point. And then again, just follow a path. Maybe make it go up and out like this, and over and out like that. All right, maybe the best you can do. All right, the next one, 0, -2. All right, here. Again, they might look a tiny bit different. All right, you can pick a path. It doesn't matter which one. Maybe something like this. All right, and then maybe out this way. That might be the best you can do. They might all look a little bit different. If yours doesn't look like your friends, it's okay. This is truly just a sketch. All right, let's look at example 2. It says plot the slope field of the function. All right, I didn't give you a table. I strongly suggest you make the table. If you kind of look back at the table, I list out every point and the derivative. So maybe let's start drawing the table. Let's say we have the points and then our derivative, what it ends up being. All right, and this one's interesting. All right, this derivative or differential equation only has an x in it. So think hard about this, that if it only has an x, all right, all the points that have the same x value are going to have the same slope. Y doesn't influence this at all. So basically each column, like this first column of points, they all have an x value of -2. They're all going to have exactly the same slope. All right, all of these points that have an x value of -1, they're all going to have the same slope. So really in this case, I don't really think we need to plot out each individual point. What I think we need to do is each individual x value, all right, to make it a little bit quicker. So this one is easier on you since the equation only involves x, it doesn't have a y. So I would just do each x value, -2, -1, 0, 1, 2, find the derivatives, and this should be pretty easy. All right, so if we do the math, plug in into our differential equation, 2x, 2 times -2, that's -4. All right, 2 times -1 is a -2. 2 times 0 is 0. 2 times 1 is 2. and 2 times 2 is 4. All right, so we need to plot these. All right, so it looks like for any x value of -2, so this whole column all the way on the left, they're all going to have slopes of -4. And again, it doesn't have to be perfect, all right, but maybe something like this would be a slope of -4. They all have the same slope, something like that. All right, moving on, -1, they all have a slope of -2. So maybe something like this. All right, they all have the same slope, and we're done with that one. All right, all the points that have an x value of 0, so basically on the y-axis, they have a slope of 0. So they're just all mini horizontal lines. So it goes pretty quick there. All right, the next one, all the points that have an x value of 1 have a slope of +2. So maybe something like this. All right, and then we have one last column. All the x values that have an x of 2 have a slope of 4. So think pretty steep, pretty positive. All right, doesn't have to be perfect. A slope of 4 is maybe something like that. All right, so that's your slope field. All right, and now we have to draw those solution curves. All right, the first one goes through 0, 1. So find that point 0, 1 and just draw some sort of graph that kind of follows the path and doesn't have to be perfect. And the other one, 0, -2, find that, pick a path. It doesn't matter which one you pick. You could go a little wide like this, something like that. All right, maybe one of your friends might have chose a different path. They might have chose a little bit further up, and that would be okay too. It really doesn't matter which one you do. You should only do one though. So just kind of stick with one for each point. All right, now we have some multiple choice here, or matching. It says match each slope field with the following. So notice what we are given. We're given the derivatives. All of our equations are y prime. We have the derivatives, and then we have to match them to the slope fields. All right, so let's just remember what these slope fields are. All right, if we go back up here, the slope fields, all right, these mini orange lines right here, all right, the slope field really resembles the original graph, right? In this case, it's not the derivative. If you remember the derivative, 2x, that graph would be a line, all right? If you think the antiderivative, what was the original? The original is x squared. X squared is a parabola. All right, so the slope field resembles the original graph. So we kind of have to do some thinking here for this problem that we're doing because we're given the derivative equations. We kind of need to think to the originals. So I would think about these and think, what's your original function? And then let's pick a slope field that maybe resembles that. So if we're kind of thinking backwards, the antiderivative of e to the x would just be e to the x. All right. If we had to find the antiderivative here, all right, remember, this is x to the first. If you add 1 to your exponent, x squared, then you divide by 2. X squared is going to be some sort of parabola. Even though it's divided by 2, that's not a big deal. We're going to be looking for some sort of, parabola shape for that one. All right. Antiderivative of positive sine is negative cosine. All right, so think about what negative cosine normally looks like. Negative cosine would be an upside down cosine, something like that. All right, antiderivative of cosine would be sine. You guys know sine usually starts on the origin, looks something like that. All right, this next one, I would multiply that out first before you try to think backwards. That's 2x minus x squared. All right, so if we were thinking, what's the antiderivative of that for our original? All right, antiderivative of that, since this is x to the first right here, you add 1 to your exponent, divide by that number, minus x to the third over 3. So these 2's cancel, but really it's a negative x cubed graph. All right, this is really what's going to determine what it looks like. All right, negative x cubed looks something like that. All right, think about what's the antiderivative of 1 over x. That's ln. All right, if you remember anything about ln, an ln graph looks something like that. All right. And these last two, these are hard. All right, they involve y. Let's hold off on those. All right, we'll kind of do process of elimination. We'll think about those once we come down to the end. All right, so let's try to kind of draw in. You could try to draw in those solution curves, like even for number 1. Think about, what does this graph look like? To me, it looks like we could fit in a graph like that. That to me looks like that negative cosine, so that would be answer choice C. All right, so we could cross that one out. Let's go to number 2. Number 2 looks like maybe it could have been a sine graph. I'm not sure. Let's kind of skip that one for a second. Number 3, that one definitely looks like a parabola. All right, you could probably fit a parabola in there. So we said our parabola was B. Let's put B there. All right. In IV, that one looks like we could put a solution curve in there. To me, that looks like our e to the x graph. E to the x was A, so we could cross out A there. All right, with V here, I don't know about that one. Over here, it looks like you could put in an ln looking graph, but if you draw one on the other side, all right, ln only has the right side. It doesn't have the left side, so let's keep moving on that one. I'm not sure about that one. VI, that doesn't look like a graph I've seen before. Neither does, we have another VI, so this should be VII, and this should be VIII. These first two look tricky, all right? But in E, if I draw a solution curve, if I just kind of pick the origin and just kind of follow a path, it doesn't have to be perfect. Be something like that. All right. To me, that kind of looks like a negative x cubed graph. All right. We said negative x cubed looks like this. It might be a little bit different because it also has this x squared in it. So I would say that's probably answer choice E from there. All right. And we got a few more. We said G and H are probably difficult. With ln, all right, I guess we got to go with ln. Ooh, we forgot something. Whenever you take the antiderivative of ln, you put absolute values, and absolute values allow you to have negative answers. So I think that's why that ln graph has another side. So that one that looks like that is going to be F. All right, we just kind of forgot our absolute values there. All right, then our one other easy one, we were looking for sine. I said number 2 maybe it looks like sine. All right, we could kind of start drawing it, and maybe it goes a little bit off the graph. I think it's just kind of the beginning of sine. We don't see it all, so that would be answer choice D. All right, and that leaves us with these. All right, something to point out, since this one only involves y, all the points that have the same y value or think are at the same height will have the same slope. So we can kind of pick between the 2 remaining ones and think which ones all have the same slope with the same y value. I think the same y value means the same height. It's like all the way across, those all have the same y value, and they're the same slope. So, excuse me. Sorry. So that would be the one that only involves y. That would be G right here. So you could tell kind of quickly without doing much thinking. And then the last one is probably the one that's left over. We could, kind of test a point and see. Usually what I do to see is I just kind of pick a random point and plug it in and just see, do the slopes even make sense? Like maybe pick the point 1, 1. If we plug those in for x and y, think about what we would get. 2 times 1 is 2. If we plugged in 1 on the bottom, we'd get 1. Our slope would be 2. So I would just kind of check, at 1 comma 1, does it look like your slope is 2, a positive slope? So let's see. It looks like this will be 1, 1. So over 1, up 1. Does it look like those could be a slope of 2? Up 2 over 1? Probably. I mean, think from the origin. This is up 2 over 1. That would be a slope of up 2 over 1. It looks like that's at that same slope. So I would say that probably works out. You could test a few more points if you wanted to be sure, but I would say that H could be our answer right there. All right, so kind of a lot of thinking goes into this. It is kind of tedious, but hopefully not too bad. All right, give the day 1 worksheet a try.